Linear induction motor. A linear induction motor is a motor which gives linear or translational motion instead of rotational motion, as in case of a conventional induction motor. So see here, figure is here. It shows a polyphase rotary induction motor. Let the stator cut along. This is the stator. This is the three-phase winding, and this is the aluminum sheets on the conductors. This is the rotor part. This is stator part. So let the stator bar cut along the line AB and spread out flat, as shown in this figure. So we can find out this forms a primary of the linear induction motor. In a linear induction motor, stator and rotor are called primary and secondary respectively. Secondary of the linear induction motor consists of a flat aluminum conductor with a ferromagnetic core. Now we'll see the applications of the linear induction motor. It is used for transportation, including the electric traction. Primarily is mounted on the vehicle and secondary laid along the track. It is used in cranes for material handling, pumping of liquid metal, actuators for door movement, and high voltage circuit breakers. It is also used in accelerator for rigs for testing vehicle performance under impact conditions. Now we will see here the principle of the linear induction motor. As we know that when traveling flux set up and travel along the length of the primary current is induced in aluminum conductor, current is interact with traveling flux. Now we'll see here the primary is act as a primary winding, this is act as a secondary winding. So what happened, there is a traveling flux is developed, which is developed in a conventional motor is the rotating magnetic field. So rotating magnetic field is a flat, so that rotating magnetic field will produce some, now in this case of translation motion, it will produce some thrust, and that traveling flux is flow, or it will produce linear force or thrust, and that force is equal to air gap power divided by the linear synchronous velocity, that is called a Vs, and slip is equal to Vs minus Vr upon Vs. This is the relative slip between primary and secondary winding, or we can say primary stator and secondary rotor. This is the torque, this is the force, thrust and speed characteristic of linear induction motor. This is quite similar to the induction motor. This is thrust and this is speed. Now we'll see here that the linear induction motor requires more air gap so that more thrust will be developed. So this is all about the linear induction motor. Thank you.